Hello, my name is Zhe. So today I'm going to talk about auctions with large language model summaries. It's joint work with Ivy, Rahul, Aranyak, and Dee, all from Google, market algorithm and machine learning team at Google Research. Okay, so I think folks already mentioned like the RAG a lot in this session, but let me do it again. So it's like usually we have a search query and we have an index function to give you some top K results, and the large language model will run a summary to give you a summation for this top K results based on this search query. So now in this talk, in particular, we're interested in how we can do this the same task for ads. So basically, it's called RAG with bits. So it's very similar. We also receive user queries, and also there's an ad index that can give us some top K ads information, and then we can run a large language model to give you an ad summary. So actually, the ad index can be controlled by auction. So there are several key questions I want to understand in this work. So basically, why can this large language model dynamically put assets together into a summary, in particular for the ads information? And secondly, can we how to incorporate Bayesian generation and how to do a price for this large language model generated summary? Okay, so actually, AI can do it all because we can just let the large language model take bits and assets and run the auction. So that, however, this proposal is very far from reality, and we don't know how to do it now. Also, it's not very interpretable and controllable, and want some a more controllable and audible approach in this work. In particular, we want to understand whether we can generalize the current auction design of the position auction into a ad summary. Okay, so what we propose is a factorized approach. So we have there are three main modules in this proposal. So first one is auction module. So we'll take the bid and some quality of ads, such as PCTR, and output a relative prominence for each ad. So this prominence will go into the large language model, and large model will summarize the ads given its allocated relative prominence and the original ad creatives. In the middle, there's also the PCTR model, which is supposed to provide the unbiased estimator for the PCTR given the prominence to the click. Okay. So there are some good properties for this factorized approach. So firstly, we can separate the auction and larger model. So auction still focus on price and allocation, larger model focus on summary. Okay, so if and also we have some good property, like if the allocation is monotone and larger model is monotone, so the incentive compatibility can be achieved. And if the PCTR is unbiased, we can also talk about how to do the welfare mechanization. And thank you. And we can also prove some universality of factorized model. So basically, it's with lots of generality to assume this. There's also some case study we call the dynamic word length summary auctions. So basically, it's strictly generalize the current position auction. So ads kept separately, but with a dynamic number of words based on prominence. And we also propose some generalized proportional allocation, which can also maximize welfare. Suppose the PCTR follows some particular format. Okay. Okay, so for more details, welcome to our poster. The paper is also online. It will appear in KDD 24 this year. Yeah, and that's it. Hope you'll see you in the poster session.